Now let's see an algorithm which will be useful in order to color the graphs, in order to obtain the chromatic number. Now this algorithm is a greedy algorithm. As always, there is no guarantee that a greedy algorithm will always produce an optimal solution. So we'll try to get a close estimate to the chromatic number. In some graphs we'll be able to get it. In some graphs you might have to work a bit more on it. I'll just show you with examples. Now a greedy coloring to a vertex ordering v1, v2, so on vn of vg is obtained by coloring vertices in the order v1, v2, so on vn, assigning to vi the smallest indexed color not already used on the lower indexed neighbors. So what is this algorithm saying is, you try to put the vertices in one order. So which means go one by one. That is what they are saying. Go one by one, and whenever you use a color or whenever you are trying to color a vertex, you see all its neighboring vertices, and out of all its neighboring vertices, whatever is the least color, you take it and apply it, right? I mean, if it is not used. So again, let's take this example. Now what they are trying to say is, start with any vertex you like. So I'll start with A and I'll assign color 1, and then go to the next one. Now you just check whether you can use 1 or not. Can I use 1? No. Can I use 2? Yes. Got it? Why can't I use 1? Because 1 is already adjacent to it. Now go to any next vertex. Yes, D. Now can I use 1? Yes, I can use it because I have not, none of its neighbors is having a color 1. That is why I am using 1. Right? Now go to C. You can go to any vertex. Now go to C. Only thing is, you try coloring it with the least possible always. Can I color with 1? No. Why? Because there is already a neighbor with 1. With 2? No, because there is already a neighbor. With 3? Yes. So go with 3. Got it? So always try coloring it from the least. Now at E, can I use 1? No. Can I use 2? Yes. Why? If you see this, 2 is not at any of their neighbors, any of its neighbors. Therefore you can definitely use 2. Now all these are over. Now coming to this, can I use 1? No, because 1 is already here. So better use 2. Okay. Coming to this, can I use 1? Yes, because none of its neighbors is having 1. Can I use 1? No. Can I use 2? No. Can I use 3? Yes. Now if you observe this, we have never used a color beyond 3, right? Therefore you can say that chromatic number of this graph is 3, but then sometimes it might be tricky with greedy algorithm. So it is better that you check in a other order. So I have followed some order. You check in other order and you just verify if you can get a better answer or not. But for this graph, chromatic number cannot be reduced below 3. What could be the reason? If you see this, there is a triangle, right, and which is nothing but a part of the graph. Whenever the part of the graph is containing a complete graph, you can never color it with colors less than that, isn't it? There is a triangle, therefore it definitely needs 3. Okay, fine. Now let's look at this one. You can start from anywhere. I'll start with this. I want to apply color 1 to this. Okay, now what about this? Can I apply color 1? No. Color 2? Yes. What about this? Can I apply color 1? No, because of this. Can I apply color 2? No, because of this. So what is the option? I have to apply color 3, right? In fact, all these 3 are present in a triangle. You have to definitely use 3 colors, right? Okay, now what about this one? Can I use 1? Yes. Fine. What about this one? Can I use 1? No. Can I use 2? Yes. Check this. Can I use 2? Yes. Right? What about this one? Can I use 1? No. Can I use 2? No. Can I use 3? Yes. What about this one? Can I use 1? No. Can I use 2? Oh, I can use 1, right? See. Oh, I can't use 1. I can't use 1. I can't use 2. I can't use 3. Right? Therefore, I have to use 4. Now, if you observe it, there is a vertex of degree, let's say some vertex is there. Let's not talk about the degree. Now it is adjacent to 3, and all these 3 are having different colors, 1, 2, 3. Then definitely I have to use a different color here. alright, because it is being cornered this way, so I cannot use already used colors. Got it? I had to use a new color. Okay, we are going to see this property again later. Now see this one. Can I use one? Yes. Can I use one? No. 2. Can I use one? Yes. Can I use one? No. Can I use 2? Yes. Can I use one? No. Yes, I can use one, right? What about this? Can I use one? No. Can I use 2? Yes. What about this? Can I use one? No, because it is adjacent to this. Can I use 2? No. So I have to use 3. What about this? Can I use one? Yes. What about this? Can I use one? No. Can I use 2? No. So what is it? You have to use 3. Okay, done. So we have by using. So is there anything remaining here? So I have covered 2, 3, 3, 3, right? So for C, can I use one? For B, can I use one? Oh, I can't use one. The reason is there is one here, right? So can I use 2? Yes, I can use 2, right? So if 2 and 2 are here and 1 is not here, I think I can use 1 here, right? Okay, so now if you see this, the chromatic number of this one is 3, right? So right or wrong, you might have to sometimes cross check it. Okay, so just change the ordering of it and then check it. Okay, fine. Okay, see this point. Now one is coloring, the chromatic number of a graph is less than or equal to capital delta of G plus 1. So what is the meaning of this one is, in a graph, where might we use lot of colors in the worst cases if there is a vertex with the highest degree. Let us say the highest degree in this case is 3, and now if this graph, all the adjacent vertices have taken 3 different colors, then definitely for this vertex you should use a different color which is different from all these 3, which means you might have to go for 4, right? Therefore, in worst case where we might consume lot of colors is, this is the only worst case. If there is a vertex with the highest number of neighbors, and if all its neighbors have taken a different color, then you cannot use the same color, right? So you have to use a different color. So that is the meaning of it. So in worst case, right, your chromatic number will never cross this. So what happens? You can assume a vertex with all its neighbors having different colors, right? So they all are having different colors, and now one more different color has to be applied to this. Therefore, your chromatic number is never going to cross this. This is the highest limit. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building. and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.